There we go. Top frames are very low now. So 1 second. This is gonna be a bit of a tough semester because I haven't really studied for a long time aside from that math studying that I did a few weeks ago. And now I have to practice a few things every day. I gotta practice math, I gotta practice coding, and I gotta practice American Sign Language because that's one of the classes I'm taking. I probably should practice bass. That's 3/4 things that I need to practice and maintain at least 3 times a week, but probably should be doing every day. That sounds hard. I don't think I've done anything every day. You know? So that's that. We have to figure out, how to deal. So hopefully though, after a while, we should be in a situation where we start learning better, because like my coding teacher is talking about how he has a bunch of research in how people learn and is hopefully going to teach people to learn better. We'll see how that goes. But I got high hopes for it because I've never really learned how to learn. I don't think people do. But those are my things to do. You gotta find yours. But we're gonna start every fucking study time out like we always do, which is with a little bit of cleaning and tidying up. For that, I'm gonna get my agenda on my little to-do list so that I can look at it later when we have everything fresh on our minds. What's a pencil? Hopefully, I won't have to do as much math. I'm kind of. So I have to do at least like 3 hours a week of math. We'll put that in the corner. We'll put semester goals here. Semester goals, 3 hours a week of math. We're kind of hoping for that amount of time coding too, but probably a little more than that. So yeah, like 3 to 5 hours Python a week, and then honestly we're just gonna stick with like at minimum 1 hour of ASL because I do a lot of that in class. So it'll be good to review, but there's not a whole lot of me that's going to be learning new things like on my own or needing to like, I don't know, practicing is on my own. It's going to be hard too because I'm going to need someone to do ASL with, sign with. And that's not going to go well. Oh, I have a sociology class. We're gonna put 1 hour of sociology. If that class makes me do any more work, I'm gonna drop that class. It's like a 100 course, and it's not my major, and there's so many other things that I'm interested in right now that I'd rather just keep going. Okay. That's that. So, to break things up today, today we do coding first. Which is more just gonna be like probably watching. We're gonna do math. And then after math, we will do. Well, there's not gonna be anything available for ASL. We'll look at sociology. We'll see if anything, if there's any like required readings or anything like that that I can do without using a book. I don't have the books yet. I get those kind of tomorrow. So, I'm gonna go to the restroom real quick, and then do some cleaning time, and then we'll get started. Okay. Yeah. Like 15 minutes. 15-minute clean time starting now. Everybody's got a little bit of tidying up to do, so this is our opportunity. We're gonna do it together. No, they didn't make me tear all my sheets out. I guess they wanted me to just tear sheets out. I was like, okay. I'm like, oh. What? More of it. Out of me. I want. Oh, grab it. All it. Any trash out. My cat's tearing it all up. Tearing it all up. Got all my hair ties. I'm gonna vacuum. Hell yeah. Okay. Today for math, I really just want to take the syllabus quiz and call it good. And then tomorrow will be a little more intense with math. But tonight, I have a lab to prepare for coding class tomorrow. It's kind of what I'm mainly focused on. And then I have a little bit of ASL stuff to do. First, let's check out the comments. What is this about? Very cool. Okay. Start here. All right, those are help sessions, but what about like assignments? Assignment. Okay, so 16-week schedule. Doing like a module every week. Okay. Let's see, is there anything? Anything in the side books? Assignments. Oh, here we go. Here we go. Oh, dang, dude. These are. Due May 8th. Is there like a recommended date to do them? Assignments. Let's try this out. Assignment reading 0. Due January 23rd, 11:59. Syllabus quiz January 23rd, 11:59. 23rd is Sunday. Okay. We are gonna do the syllabus quiz tonight. Maybe we won't. I don't really know. Well, we'll definitely do the reading tonight. Good to know that we just have to have reading 0 in the bag by Monday or by Wednesday. Our lectures are on Wednesday. I mean, it says by Monday, but yeah, that's good to know. And then this one's January 25th, which is Tuesday, but like that's 11:59, so that's really the 26th. Okay, I need to write this down. Fuck. Alright. That awkward moment when you try to move to avoid your cat, and then your cat avoids you, or at least tries to, and then you punt your cat. Feels bad. Anyway, reading 0. That's our big thing tonight. History and basics. This is 1.77 different things. Won't get credit unless I browse to it through Canvas. Okay. Oh, wow. Okay. Come on, buddy. What do you mean? How to join Microsoft Teams. Whoops. Need to do a different email. Use another account. This one, yay. They remembered. Uh. Okay, sick. I am part of the MS Teams already. So you can let me read my dang thing, please. Where do I make the account? I gotta get an app. Let's do the student web app. Okay, there we go. Sign. Select institution. Colorado State University. Go. We didn't find an iClicker associated with your institution email. Do you have an iClicker account using it? go. Let's go. Using an iClicker remote. I can. Oh, this is how we're gonna. Oh god, dude. Uh. Hmm. Hmm. It's already becoming a pain in the patoot. There we go. Wow, this is ridiculous. So I can't... So this doesn't work as its own clicker. What's the point of this app then? It's just to register a clicker. It's dumb. I thought I wasn't gonna have to go to the bookstore this year, but I guess I do now. Damn it. Wonder if there's like a clicker at Walgreens that I can buy or something. That would be like top notch. They would be coming in so clutch with that if that was the case. Anyway, I can probably... Can I, you know, do reading 0 now? Not yet. Yeah, I gotta join a help session. What would be a good time? These sound like terrible times to do it. What am I doing? Let's see, 9 to 10 I got, on Friday 9 to 10 I got fucking nine to 10 got my ASO class, then 10 to 11 on Friday I don't have any. So maybe I should get like a 10 to 11, 10 to 10:50 in the computer science building, 225. That's for me. Can I do my stuff now? Like, Jesus Christ. I have to do the syllabus quiz. Alright, fine. I hate syllabus quizzes. Like, why? Probably not that. I don't know what that is. Student case management? Student resolution center? I don't know. I'm just gonna do Student Resolution Center. Brave space or safe space? Oh, That was back in policies. Ugh. Considered a brave space. Oh no! A brave space! May you resubmit your reading assignment flaps after your first submission. Yes. Select the most accurate statement concerning knowledge check. Oh damn, I got a lot of them wrong. Okay. Appropriate gray, inappropriate, appropriate gray. With that said, this course is considered a brave space. This does not exclude it being a safe space, but it's... What? Was I supposed to say go Rams? I don't fucking understand. Let's score at least 3. God. Gonna put both then. Fuck you. Alright, I got everything else right. 3.4 out of 4. Thank God. Jesus Christ, what is going on with my email? That is an insane validation code. Holy shit. Okay. You suck my ass. Finally. Oof. We made it. Okay. Oh god. This is interactive. Okay. Well, let's start from the beginning. Computing history. Computers originated from telephone switches in the early 1900s. Engineers realized switches could be used performing calculations. With switches on position meaning 1 and then off position 0. The first computers built in the 1940s had thousands of switches and occupied entire rooms. Early computers were largely used for military purposes like code breaking in World War II, calculating the paths of bombs. So cute. Figure 111, 1940s computers with thousands of baseball-sized switches occupied entire rooms. Shrinking switches led to single-chip computers. Today, that room-sized computers fits the chips the size of a pin. Jesus Christ. Engineers who reduce switch sizes by half about every 2 years. Trend known as Moore's Law. Such halving is remarkable. Try repeating folding a sheet of paper in half and note how quickly the size shrinks. More than 7 paper folds isn't even possible. Is that true? Okay. You're bullshitting me. 7 folds isn't possible? Okay, 1 fold. We got 1 fold right here. Find that nice. Okay. Ready? I'm gonna go hamburger, 2 folds. We have 2 folds. Now we're gonna do 3. Okay. Still looking doable. 4. Okay. The 4th one. 5. Okay. It's looking real small now. 6. Yeah. Oh, bro. Okay, I got 6. Here we go, number 7. Watch out. You lied. You lie. There's 7. Oh, it's right there. Now try 8. I can't do 8. Well, you should update that to 8. I'm gonna write that in my student review. I'm gonna try to remember that. I'm really close to making like a really shitty joke to this person I've been talking to, but I'm not gonna do it. Like, you don't. Anti-Semitic jokes are only jokes that you make with people you know are gonna take it well. Especially when you don't mean them. Okay. I don't know. Like 40s. First computers occupied entire rooms. That's the. By the 1970s, an entire computer could fit on one coin-sized device known as a chip. Oh no, this can go here. Yay. The information age. Computers are a recent phenomenon, and yet are rapidly transforming human civilization. Civilization's earlier agricultural age lasted many thousands of years. The industrial age, starting in the late 1700s, transformed civilization toward manufacturing goods, leading to mass migration to cities, creating strong nations, world wars, doubling of lifespans, and this dramatic world population growth, and more. The information age just began in the 90s. Human activity shifting from traditional history to creating, managing, using computerized information. In just one of those few years, how people work, learn, communicate, or entertain themselves has already changed dramatically, but the ultimate impact likely remains to be seen. Yeah, dude. Like, that didn't really occur to me until, like, I don't know, after I got out of college. It's like, we just got introduced to computers. Like, we're just hitting this weird new, like, age of the world and technology and stuff, and it's like, you need to fucking get on the meta. hope she takes that as like. I hope she takes that as funny. Because I just want to know, like, what. Because now I'm learning her family's Jewish, so now I just want to know if she knows, like, where, you know? What kind of Jew? What kind of. So I was like, do you know what demographic your family's from? And then I'm like, whoa, that sounds like. Well, like, that sounds like she could just say whatever. So I'm just like, what kind of Jew are you? It just sounds weird to say. Like, I don't mean anything mean by it. Ugh. Truth. No. Next. Historical figures in computing. Very Ashkenazi. Very cool. In 19th and 20th century, computing devices and procedures are the precursors to the technology used today. Those responsible for these advancements are considered the forefathers and foremothers of the information age. Joseph Marquis Jacquard, French silk weaver and inventor. In 1804, he invented the Jacquard loom, a weaving device noted for simplifying the manufacturing of textiles. The loom could be programmed to weave specific patterns using a chain of punched cards. Using different cards allowed the woven patterns to change without modifying the mechanics of the loom. The Jacquard loom influenced modern programmable devices such as the IBM Digital Compiler. Pretty cool. Charles Babbage, British mathematician, philosopher, mechanical engineer, inventor, regarded as father of the computer. Babbage invented the first automatic mechanical computer, the difference engine, which was used to calculate polynomial functions. Well, that's pretty fucking sick. The analytical engine was the difference engine's successor, intended as a programmable computing engine. To support general purpose computing, the following components were added. Arithmetic logic unit used to perform arithmetic called a mill. Conditional logic used to perform conditional branching and loops. Memory, the machine's memory could hold over thousands of numbers containing 40 decimal digits. Punch card reader used to input programs and data via punched cards. Owned a woven puppet portrait of Jacquard, which inspired Babbage to use the punch cards for the analytical engine. Well, that's cool. It's all cumulative. Ada Lovelace, British mathematician, who is often referred to as the first computer programmer. Augusta Ada King Noel, Countess of Lovelace, was commissioned to translate a document about Babbage's analytical engine from French to English. She augmented the document with her own notes, tripling the size of the original document. Holy cow. Note G detailed the steps to compute the Bernoulli numbers and is considered to be the first computer program. Lovelace was also one of the first to predict the use of Babbage's engines beyond numerical calculations and instead have far-reaching applications in general computing. It's so cool. I don't know what that means, but it's so cool. The Jacquard loom and analytical engine both used punch cards, right? Leave my food alone. Butthole. Got your own food. Check my answer. Correct. Blank is considered the first computer program. Ada Lovelace. Yeah. She is our baby. Our beautiful lady. Yeah, dude. Oh, they added things. Arithmetic logic ALU used to perform arithmetic called a mill. Instructional logic used to perform conditional branching and loops. Memory. The machine's memory could hold 1,000 numbers containing 40 decimal digits. Punch card reader used to input programs data via punch cards. So what do I need to add? What? Analytical engine included a blank to perform arithmetic operations. Arithmetic logic unit. Algorithm to compute the Bernoulli numbers and said to be the first computer program was titled Note G. Herman Hodderith was an American inventor and creator of the punched card tabulating machine. Tabulating machine was an electromechanical computer used to summarize data stored on punched cards. He also invented a key punch machine to create the punched cards. It's amazing. Like, code was basically just on punched cards before it was able to be logged into like computers and shit. In 1911, Holler's company, Tabulating Machine Company, merged with 4 other companies to perform the Computing, Tabulating, Recording Company, CTR. In 1924, CTR was renamed the International Business Machines Corporation, or IBM. IBM printed and sold millions of punched cards, and punched cards tabulating machines remained in use until the 70s. Alan Turing was a British computer scientist and mathematician who became well known for his cryptologic methods during World War II. In the 1920s, German translated secret messages using a machine called Enigma. Alan worked at Bletchley Park to develop an mechanical cryptanalytic, there we go, machine called the Bomba to decipher the intercepted German messages. Deciphering these messages proved instrumental in helping the Allies win the war. Turing also greatly contributed to the study of artificial intelligence by developing the Turing test experiment. Described in Computing, Machinery, and Intelligence, the Turing test evaluates if a computer is considered intelligent, proposing a series of questions. The computer passes the test if the computer's response cannot be distinguished from a human's response. That's just... oh my god. I wonder how people feel about the Turing test today. Like, I didn't know that the Turing test was invented that far back. Grace Hopper was an American computer scientist and mathematician. Credited with developing the first compiler, Hopper served in the U.S. Navy Reserve, also known as the Women's Reserve, during World War II. While in the Navy Reserve, Hopper was a computer programmer on Harvard University's Mark I computer. In 1949, she began work on the Universal Automatic Computer (UNIVAC) project and helped to develop the UNIVAC 1 computer. While working as a computer programmer, she suggested creating a programming language that used English words instead of assembly language or machine code to make programming more accessible. To facilitate a higher level programming language, Hopper invented the first programming language compiler, which converted mathematical notation using English words to mathematical code. Mathematic and Flowmatic were in early compiler-based programming languages developed by Hopper's team UNIVAC. In 1959, Hopper served as a technical consultant to the committee that defined COBOL, Common Business Oriented Language, introduced as an English-based programming language designed for business use. COBOL is still used in business in the 21st century. The language is often criticized for being too verbose. Popularization term computer bug is still sometimes attributed to Grace Hopper's team at Harvard University. While working on Harvard Mark II computer, Hopper and her staff discovered that a moth had gotten stuck in one of the computer switches, interfering with the computer's operation. The moth was removed or debugged, and the issue was resolved. No! That's where debug comes from! No! Dude! Oh my god! That's so good, dude! That's so good! Oh my god. The popularization of the term computer bug is sometimes attributed to the Grace Hopper's team at Harvard University. While working on Harvard's Mark II computer, Hopper and her staff discovered that a moth had gotten stuck in one of the computer switches, interfering with the computer's operation. The moth was removed or debugged, and the issue was resolved. God, that's funny as fuck. There's 7 of these. There's the music. Programming general. Computer programming basics. Computer programs are abundant in many people's lives today, carrying out applications on smartphones, tablets, laptops, powering businesses like Amazon, Netflix, helping cars drive, planes fly, much more. Computer program consists of instructions executing one at a time. Basic instruction types are input. Program gets data, perhaps from a file, keyboard, touchscreen, network, etc. Process. Program performs computations on that data, such as adding 2 values like x and y. Output. Program puts that data somewhere into a file, screen, network, etc. Program use variables to refer to data like x, y, and z below. The name is used to a variable value varying as a program assigns a variable like x to new values. Okay, so what is this? Participation activity. 1.3.1 basic computer program. X get next input, y get next input, z equals x plus y, put z to output. So x equal, okay. Start. So the next instruction is to get, okay, so the first instruction is to take 2, the next instruction is to add 5, or is to take 5, and then the third instruction is to take them and put them together, and then the fourth instruction is to take the value and put it as the output on the screen. That makes sense. Program has 4 instructions. Suppose a new instruction was inserted as follows: blank z plus y. Add 1 more to the z. New instruction. Put z to output. What was the last instruction? And output to the screen. What was the last instruction? Then output. Would it, so here's the question, would it be 8? It would be 8, okay. It's either going to be 8 or 7. I just don't really know if coding would, if it was going to understand that that is the new z or what. Consider the instruction z equals x plus y. If x is 10, y is 20, then z is assigned with 30. Okay, that's a good thing to note. So this isn't saying that z is always going to be the equality of x plus y. This is saying that we're taking these 3 different variables, we're applying different values to them. We're having 2 set values for x and y, and then z is the value that's combining these 2 set values. Program is like a recipe. Some people think of a program as being like a cooking recipe. Recipe consists of instructions that a chef executes, like adding eggs or stirring ingredients. Likewise, a computer program consists of instructions that computers execute, like multiplying numbers or outputting a number to a screen. Pretty cool. First programming activity. Below is a simple tool that will allow a user to rearrange some pre-written instructions in no particular programming language. The tool illustrates how the computer executes each instruction one at a time, assigning variable and with the new values throughout and outputting values to the screen. Or printing values to the screen. Also another word for output. Good shit to know. Execute the program. Observe the output. Click and drag the instructions to change the order of the instructions and execute the program again. Not required. Points awarded just for interacting, but can make the program. But can you make the program output at a value greater than 500? How about at a value greater than 5,000? Okay, so I can't change these two. But m equals 5. N equals m times 2. M equals m times m, put m. And m plus 15. Okay, so the best thing. So we're going to take m plus 15, then m times m, then m times 2. Let's run that. Okay, 800's nice. Let's try flipping these two and see if we can get over 1K. That's what I'm talking about, baby. M plus 15, double that. So then it's 30. And then it's 30 times 30. Wait, no, it's not? Okay. So we start out m equals 5. Put 5. We're going to put, because 20. Then the times 2 is 40. Then, that's so sick. I am the smartest man alive. Which instruction completes the program to compute a triangle's area? Base equals get next input. Height equals get next input. Assign x with base height. Blank, put x to output. Okay, wait. Assign x with base times height. Base times height times 2 is not the formula for a triangle's area. Well, So, oh, okay, so the triangle's area is half times base times height. I didn't know that. Wait, so that which construction completes the program to complete the average? X equals get next input, y equals get next input, z equals get next input, put a to output. A. Computational thinking. Mathematical thinking became increasingly important throughout the industrial age to enable people to successfully live and work. In the information age, many people believe computational thinking or creating a sequence of instructions to solve a problem become increasingly important for work and everyday life. A sequence of instructions that solves a problem is called an algorithm. A common way to become familiar with algorithms is called turtle graphics. To instruct a robotic turtle to walk a certain path via instructions like turn left, walk forward 10 steps, bend down. The 6 instruction algorithm shown below draws the triangle. Press run to see the instructions execute from top to bottom, yielding a triangle. You can modify the instructions to draw a square, question mark. Hit pen down, forward 100, left 90, forward 100, left 90. Keep going. Experiment to see what else you can draw.
That in madness lies sanity.
Let's see it. Nice. Computers in the 40s and 50s are large, expensive machines used for government and business purposes. Initially, just a few existed worldwide, costing millions of dollars, weighing over a ton, and occupying entire rooms. Computer chips were invented in the 50s and regularly improved to have more switches and lower costs. More businesses began purchasing computers in the 60s and 70s. In the 80s, people began purchasing desktop laptop computers for home use. 2000, computers began appearing in the form of electronic tablets, both computers and smartphones too. Desktops are going down. Embedded computer is a computer inside another electrical device like a TV, car, printer, thermostat, satellite, etc. Thus, beyond business and personal computing device like PCs, tablets, and smartphones, computers exist invisibly in nearly anything electrical today, too. That's pretty cool. Embedded computer is a computer inside of a personal computer. Yes. Wait, not true. Modern cars and computers. Correct. The number of embedded computers are greater than the number of desktops and laptops. That could be true. Yeah. Computers are built from connected switches that are like light switches that are either on or off. One is called 1, off is 0, a single is 0, or 1 is called a bit. 1011 is 4-bit, 8 bits, like 11000101 are called a byte. Humans represent information using characters or numbers like Z42. Computers need a way to represent characters and numbers using zeros and ones. All data stored in a computer is represented by using bits, including numbers, letters, symbols, and multimedia. Let's see. Character is a letter, symbol, or digit number. Basically, each item on a keyboard is a character. Each character can be given a unique bit code, which stands for American Standard Code of Information Interchange. It's a popular code for characters developed in 1963. ASCII uses 7 bits per code and has codes for 95 characters. Wild. That's crazy. What is the 7-bit code for lowercase a? Blank space. What 2-letter word does this sequence of bits represent in ASCII? Pay attention to upper/lowercase. H just says hi. Okay, so 500 times 8. 5 times 8 is 40, so 4,000. Computers do many calculations, so because early humans represented values using 10 fingers, humans developed base 10 numbers known as decimal numbers to refer to 10, but computers can only represent two values, 0 or 1. So use base 2 numbers known as binary refers to 2. Rather than each digit being a power of 10 and holding 0 through 9, each digit is a power of 2 and holds 0 or 1. Experiment with the below tool to understand how zeros and ones of an 8-bit binary number represent the whole number to 0 to 255. Go all the way up to 255, 1. That's right, so it's got a 2, 3. So if that's there, okay, this is value of 1. This is value of 2. This is also a value of 1 still, so that makes it a value of 3. But you get a value of 3 some other way. This is a value of 4 when you add that to value of 5, 101. So 1, 2, 4, 8, 16, 32, 64, 120. I 2, 1, 2, 3. I gotta think of it as like thing flipped. Okay, now it's gotta flip back, and then this flips, and then it flips back. And, oh wait, no. And then that flips, and then this flips, and then this flips, and this flips, and this flips, and this flips, and this flips. No. And this flips, 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 and this flips. This flips, and this flips. Oh no. No, then this adds. Then this flips. Wait. 11. Oh. 13. 14. 15. 16. 17. 18, 19, 20, 21, 21, 22, 23, 24. Okay. Let's try 1100 as a decimal number. That's gonna be 12. What is a 7 as a 4-bit binary number? Is a 4-bit, well, 111. Like that? Yes. Okay, that's the decimal value in binary. This one. Nice. Next. Nice. Next. Nice. Next. Characters and numbers are encoded and stored in the computer's memory. Each character has a unique bit code. Okay. Which are stored sequence of bit code. Okay. Symbols of spaces also characters stored in the memory space. And numbers are too, aren't they? No, numbers are stored in finite. Okay, break time. Take a quick break, and then we're gonna finish this up. Then we might call it for tonight. Do more of this tomorrow morning.
How odd that it should end this way for us after so many stimulating encounters. Almost regret it. When shall I find a new adversary so close to my own level? Try the local sewer. You and I are very much alike. Archaeology is our religion.
This is insane.